All right, this is example 1 and 7.3, just where we practice the skills. And it is the idea of just trying to rewrite each of these numbers or each of these powers with a base 3. So 3 to the power of something is 27, and 3 to the power of something is 9 squared, and so on. And I think it is really important that if you're stuck with this, then, I mean, certainly in this question, because they tell you it's base 3, it might be worth thinking about the function of y equals 3 to the power of x. Because really, if we examine this, and I'll use the positive numbers, although we could do negative as well, that if we look at the values of x and y, then really what's going to happen is as we increase these values of x, what we're going to start seeing in this kind of right-hand column here are ultimately powers of 3. So 3 to the power of 0 is 1, 3 to the power of 1 is 3, then we have 9, 27, 81, 243, and 729. Now, really importantly, remember what equation we put this into. It was y equals 3 to the power of x. So 1 is 3 to the power of 0, 3 is 3 to the power of 1, and so on down that list. Now, the reason that that's so important is, I mean, A is a pretty simple one, I think. It's the idea that 27 is 3 to the power of 3. So if we had 27 in an equation, we could replace the number 27 with 3 cubed, and then likely have to do some exponent rules after that. And that's really what this example is in here for. 9 is the same thing as 3 squared. Now, that's really important. That means the number 9 can get replaced by 3 squared. So in the question, we had 9 squared. I'm going to say that that's equal to 3 squared squared. And one of the rules that you learned with exponents a long time ago for sure is that when you put a power on a power, you multiply those. So this would be 3 to the power of 2 times 2, or 3 to the power of 4. Now there's a nice kind of double check here, is that if you had your calculator and you took 9 squared, you would get 81. Well, if I take 3 to the power of 4, I get 81 as well. So those are numerically equivalent to each other. All right, now that brings up a pretty good point, because in this last question, I'm going to use the fact that 27 is 3 cubed and 81 is 3 to the power of 4. So the only other thing I'm going to do here is an exponent rule that's kind of sneaky. A lot of students don't remember it, but if we have, and maybe I'll write it as the nth root of x is actually x to the power of 1 over n. And the reason why that's so important is I'm going to do a few things in here. 27 is going to get replaced by 3 cubed, and that's still to the power of 1/3. Then I'm going to multiply by, so the outer bracket is squared, and then inside that 81 is actually to the power of 1/3, but 81 is 3 to the power of 4. So one of the challenges in, chapter 7 is that those exponent rules that, maybe you took for granted or didn't learn quite as well as you should have are really going to come back with a vengeance. And you have to make sure that you're comfortable with the idea that when I put a power on a power, I multiply exponents. When I multiply common bases, I add exponents. When I divide common bases, I subtract the exponent in the denominator from the exponent in the numerator. And we'll run into these as we go through the list, but it might not be a bad idea to go back. Hopefully you have your notes. If not, there's always Google, and look at some of those basic exponent laws. And I think I'll probably maybe finish this lesson and I'll write down a few of them when I show the assignment page. All right, what's going to happen here to finish the question is we're going to put those powers to a power. So 3 cubed to the power of 1/3 is 3 to the power of 3 times 1/3, which is 3 over 3. I'm going to multiply that. Here it's 4 to the power of 1/3 to the power of 2. So that's going to be 3 to the power of 4 times 1/3 times 2, which is 8/3. Now, before we get too over the top with, 3/3 is 1 and so on, because we have a common base and they're multiplying, this is 3 to the power of 3 over 3 plus 8 over 3, which is 3 to the power of 11/3 because they have a common denominator. There is another way of writing that. I would certainly prefer this at this point, but just to practice those exponent laws, we need to know that that is the cube root of 3 to the power of 11. And like I said, I'll put a little summary of those exponent laws when I put up the assignment for this lesson.